Suppose you have a general sequence, which is 2n divided by 3n plus 1. And then take a look at the series itself. I'm going to check to see if this is a convergent sequence, a convergent series, or not. In terms of a sequence is a function to check if the sequence is convergent or not. We need to take the limit of the sequence, and that's it. If the limit exists, then you're going to say that, hey, this sequence is a convergent sequence. The limit of 2n divided by 3n plus 1 as n goes to infinity is equal to, well, intuitively you can say that, hey, I have 2n on the numerator, on the denominator I have 3n plus 1. Since 2n goes to infinity and 3n goes to infinity, the constant here is 1, so you can find a unique value, which is 2/3. Or you can do the algebra. The algebra was, we divide everything by n. So here you get 2n divided by n divided by 3n over n plus 1 divided by n as n goes to infinity. And then simplify this by as much as you can. You have the limit of 2 divided by 3 plus 1 over n as n goes to infinity, which is basically gives you 0 here. So you have the limit of 2/3, which is constant, or 2 divided by 3. And then you're going to say that since the limit is a unique numerical value, the sequence is a convergent sequence. Since the limit of 2n divided by 3n plus 1 as n goes to infinity is equal to 2/3, and it is a unique numerical value, so the limit exists and the sequence is a convergent sequence. Convergent sequence. So far we have a convergent sequence, but what if we take the elements of this sequence and form a series? What about this series? Is this series a convergent series? Remember the theorem. We had a nice theorem. The theorem said if a series like the summation of an and start from goes 1 to infinity is convergent, then the limit of the general term as n goes to infinity must be equal to 0. We also saw an important note. We had a note that tell us if the limit of an as n goes to infinity is not 0, then for sure you can say that the series an and start from 1 goes to infinity is a divergent series. So let's check this. We already found the limit of the general term. The limit of the general term is 2/3. So since the limit of general term is 2/3, it's not equal to 0. For sure, you can say that this series is a divergent series. So since the limit of an as n goes to infinity, which is the limit of 2n divided by 3n plus 1 is equal to 2/3, and it's not 0. So we can say that, or we can conclude that the series is a divergent series. The difference between a convergent sequence and a divergent series. So let us recap, everyone. We gave you a sequence 2n divided by 3n plus 1, and out of that sequence we build a series. In terms of convergence, divergence of a sequence, the sequence itself is a convergent sequence. Why is that? Because a sequence is basically a function. When you have a function, to analyze the convergence, divergence of that function, you just need to take the limit. When I take the limit of that sequence, the limit exists and it is 2/3. So you're going to say that, hey, since the limit exists and it's a unique numerical value, you're going to say that, hey, you have a convergent sequence. But what about the series? If I take this sequence and construct a series out of it, I'm going to check these theorems first. The theorem says if a series is convergent, then the limit of the general term must be equal to 0. And out of that, we found a contrapositive, which says if the limit of the general term is not equal to 0, then for sure you can say that you end up with a divergent series. But we already know the limit of the general term is not 0, it is equal to 2/3. So since the limit of the general term is not 0, for sure you can say that you end up with a divergent series, everybody.